In question 2 of our series, where we determine an empirical formula from combustion analysis, we are asked, upon combustion, a 0.8009 gram sample of a compound containing only carbon, hydrogen, and oxygen produces 1.6004 grams of CO2 and 0.6551 grams of water. Find the empirical formula of the compound. Notice that I've given this question a difficulty rating of hard, but to make things easy for us, I will be borrowing some information that we found in question 1. Let's start the process by finding the molar mass of CO2 and H2O. For that, I'll borrow some information that I found in question 1. In question 1, we found the molar mass of CO2 to be 44.01 grams per mole. 44.01 grams per mole. And the molar mass of water happened to be 18.01. 18.01. Now, if you want information about how I found that, make sure to watch question 1 and I'll go through the math involved. The next thing that I want to do is find out the amount of moles of carbon and hydrogen given their masses. So I'll take 1.6004 grams and multiply it by the reciprocal version of this number. Reciprocal means flipped, and here's what I mean by that. I'll take 1.6004 grams and multiply it by 1 mole over 44.01 grams. Notice that originally the moles were at the bottom, but I put it at the top and I place the grams at the bottom. And you can do that for any number that is a rate. Technically, this is a rate because we have one unit over another. So you can flip it as you wish. And I'm flipping it so that this gram unit will cancel out with this gram unit, leaving us only with moles. The same thing can be said for H2O. I'll take the mass of water, which was 0.6551 grams, and multiply it by 1 mole over 18.01 grams. Look what happens. The mole unit is the only one that remains as the gram units cancel out. Using our calculator, we have 1.6004 divided by 44.01. We get 0.03636, 4 significant figures, because this one has 4 significant figures. And over here, 0.6551 divided by 18.01, and we get 0.03637. These two numbers represent the amount of moles of CO2 and H2O respectively. Now, using these two very important numbers, which I'm highlighting, I need to find out the amount of moles of carbon and hydrogen. And I can do that by multiplying this number, for example, by the amount of carbon atoms within one molecule of CO2. And here's how you do that. There's one atom of carbon and there's one molecule of CO2 here. So I'll write down 0.03636 moles of the total amount times 1 carbon mole over 1 CO2 mole. This will cancel out with this, leaving me with the amount of carbon moles. So 0.03636 times 1 is the same thing. This is the amount of moles of carbon within this molecule. Let's do the same thing for the next one. We have 0.03637 moles, and we have 2 hydrogens, so we multiply by 2 hydrogens, hydrogen moles, over 1 mole of H2O. This cancels out with this, leaving us with, using our calculator, 0.03637 times 2. That gives us 0.0727 0.07274 moles of hydrogen. Remember that we're starting off with a fuel that has C, H, and O. So I'm going to write down 0.03636 of carbon Similarly, 0.07274 of hydrogen. And now we need to find the moles of oxygen. We have to find out how much grams is within this amount of moles. And similarly find the mass of hydrogen within this mole, add that up, and then subtract it by the total mass of 0.8009. And this will tell us the amount of oxygen. So let's start with finding the mass of carbon. I'll take 0.03636 moles and multiply that by the molar mass of carbon, which you can find on your periodic table to be 12.01 grams per mole. This mole unit will cancel out with this mole unit. We'll do the calculation in a moment. Let me set up the next one. 0.07274 moles times 1.008 grams per mole, and that's the molar mass of hydrogen. This mole unit cancels out with this one. Let's use our calculator. 0.03636 times 12 gives us 0.4363. 0.4363 grams. And now these two numbers multiplied, 1.008, and that gives us 0.0733. 0.0733 grams. I'll add these two numbers up and subtract from the total. Adding this number to 0.4363, 0.5096, 0.5096 grams, and that represents the mass of carbon and hydrogen subtracted from 0.8009, 0.8009. Let's use our calculator. 0.8009 minus what we just found, and we get 0.2912. 0.2912 is the mass in grams of oxygen. Finally, we have to convert this number using the molar mass of oxygen to get the amount of moles, and that will represent the subscript. 0.2912 grams times 1 mole of oxygen over 16.00, and that can be accessed through your periodic table. This number divided by 16, that represents the amount of moles, 0.01820 moles of oxygen. And I'll place that number right here. Now, the smallest number here is 0.01820. We have to take that number and divide each of these subscripts by that number. So I'll divide this by 0.01820. That becomes a 1. Divide that by that, and divide that by that. Without writing it down, I'll just do it on my calculator. 0.03636 divided by 0.01820. That gives me approximately 2. So this becomes 2. We have C2. Now let's find out the amount of carbon. 0.07274 divided by 0.01820, and that gives me approximately 4. So our empirical formula for this fuel is C2H4O. And there you have it. That is how to determine an empirical formula from combustion analysis.